calculating the definite integral turns into a simple substitution process once we know how to do the integral. The fundamental theorem of calculus tells you if you have a function fx, let's say for example fx equals 2x, and we want to do a definite integral, meaning we've defined the interval from a to b. We have 2x, this is its graph, and we want to get the area from a to b, a here and b here. So now what do? First we find its integral, capital F. Notice that here we substitute into capital F, its integral is x squared. Then we substitute the last limit, which is the upper one, minus the first limit, which is here. So let's look at an example. If we have f bar x equals x, this is its graph here. Now we want to get its integral from 3 to 6. We want to get this area. First we find capital F, which is x squared over 2. Then we substitute the 6 into this capital F. We put the 6 here. 36 over 2 is 18. Minus, we substitute the 3, which is 9 over 2. This result, 4.5, comes out, and it's the area from here to here. Let's take a second example, an exponential function. If its base is e, that means its integral is itself, the integral of the exponential function is itself. Here we want to get the area from 2 to 4, or the integral from 2 to 4. Same thing, we substitute in the 4, minus, we substitute in the 2, and calculate. So this is the result. Okay, the constant c, notice that we are ignoring it. Why? Because even if we put the constant c, as long as the integral is definite and we substitute into it, for example, the function 2x, its integral is x squared plus c. If we substitute here with the 3, it becomes 3 squared plus c, then minus, we substitute with the 1 squared plus c. Here the negative carries over here, and we get plus c minus c, they cancel each other out. That's why in the definite integral we always ignore the constant c. What if we reverse the interval of integration, meaning we integrate from b to a instead of from a to b? We just add a negative sign. And essentially, if we substitute in the correct way, a negative result will appear. So for example, if we have 2x, its integral is x squared. We want to substitute, we always start with the upper minus the lower. So it becomes 9 minus 1, 8. If we reverse it, let's put the 3 lower and the 1 upper. We always start with the upper minus the lower. So we get 1 minus 9, giving negative 8. So this means that if the integral is adding for us and we're heading to the right, for example, an area, this is what's meant by the sign of